Good morning. Our lecture today is about Cramer's rule. Returning back to solving a system of equation using a matrix, we said that if x are the variables that we would like to find their values, so we can find the value as inverse of matrix A multiplied by D. So we can write this as if it's the required is to find the value of x1, x2, and x3, x1, x2, and x3 vector x equals 1 over the determinant of matrix A multiplied by the cofactors, cofactor 1, 1, cofactor 2, 1, etc. And this is going to be multiplied by D1, D2, and D3. So we can write this in the form of, if you would like to find the value of x1 dash, for example, x1 dash can be calculated as 1 over the determinant of matrix A multiplied by the summation of Dij multiplied by the cofactor Ij starting from I equal 1 up to n. So let's take an example in order to understand the main idea of Cramer's rule. If we have a system of equation 5x1 plus 3x2 equals 30 and 6x1 minus 2x2 equals 8, so we can convert this into matrix as 5 and 3, 6 and negative 2. This is matrix A. It will be multiplied by x1 and x2. This is vector x. This is equals 38. This is vector D. So now we would like to solve this system, this matrix using Cramer's rule. According to Cramer's rule, we are going to replace the first column of the first step is to calculate the determinant. And then the second step is to replace the first column of matrix A by the column vector D. Step 2, replace the first column of the matrix and then calculate the new determinant. The new determinant is known as determinant A1. As the subscript 1 indicates that the first column has been replaced by D. So this one means that we have replaced the first column by the values of D. And then we are going to repeat this for each column in the main matrix or matrix A. After that, say for example, the matrix is 3 by 3, so we have to replace the second column with D and calculate the determinant, and this will be determinant A2. And with respect to the third one, it also will be replaced by D and then calculate the determinant, and it will be determinant A3. Now we would like to find the value of x1 and x2, and if there is x3, so it will be for x3 as well. It will be calculated as 1 over the main determinant multiplied by determinant A1. In case of P2, 1 over the main determinant multiplied by determinant A2, and so on. This method is known as Cramer's rule. Okay, let's return to our example. As we said that our example, this is matrix A. And this is x1 and x2. This is D. Now we are going to calculate the main determinant of the matrix. It's calculated as 5 multiplied by -2 minus 3 multiplied by 6. So it is -28. So this is the first step. Now we are going to move to the second step, as we are going to replace the first column in the matrix by the values of D. So the new matrix will be 30 and 8, 3 and -2. Then we have to calculate determinant A1. So it will be 30 multiplied by -2 minus 3 multiplied by 8. So it is -84. And then we are going to do the same with respect to the second column. So this is the matrix 5 and 6. And we are going to replace column number 2 by 30 and 8. And then we have to calculate determinant A2, which is calculated as 5 multiplied by 8 minus 30 multiplied by 6. So it is -140. Now we would like to find the value of the x1 dash and x2 dash. As we said, it's calculated as the determinant A1 divided by the main determinant, and with respect to B, it is determinant A2 divided by the main determinant. A1 is calculated as -84 divided by the main determinant, which is -28, so the value equals 3. And with respect to x2, it will be -140 divided by -28, so it's 5. So this is the solutions for x1 and x2 using Cramer's rule in case of 2 by 2 matrix. Now let's take another example for 3 by 3 matrix. This is the system of equations that we would like to solve. And the required is to find the value of x1, x2, and x3. So first of all, we have to convert the system of equation into matrix notations. So matrix A will be 7, -1, and -1. 10, -2, and 1. 6, 3, and -2. So this is matrix A. This is multiplied by vector x, x1, x2, and 3 equal vector D 0, 8, and 7. So as we said, that the first step is to calculate the main determinant of this matrix. Main determinant is calculated as 7 multiplied by -2 multiplied by -2 minus 1 multiplied by 3 plus, actually it's minus -1 multiplied by 10 multiplied by -2 minus 1 multiplied by 6 minus, it's plus -1. So it is -1 multiplied by 10 multiplied by 3 minus 6 multiplied by -2. So the main determinant is -61. As there are 3 x's, so we have to calculate 3 other determinants. With respect to determinant A1 is going to be calculated after the replacement of column number 1 with the value of D. D equals 0, 8, and 7. And this is the rest of the matrix as it is. Now we have to calculate determinant A1. It's calculated as 0 multiplied by -2 multiplied by -2 minus 1 multiplied by 3 minus -1 multiplied by 8 multiplied by -2 minus 1 multiplied by 7 plus -1 multiplied by 8 multiplied by 3 minus 7 multiplied by -2. So it is -61. Now we are going to move to the second determinant, which is calculated as in order to be able to calculate the determinant A2, we have to replace the second column of matrix A by D and then we have to calculate A2 as 7 multiplied by 8 multiplied by -2 minus 1 multiplied by 7 minus 0 minus, of course it's plus -1 multiplied by 10 multiplied by 7 minus 8 multiplied by 6. So it will be -183. With respect to the third determinant, it's gonna be calculated after the replacement of column number 3 with the value of D. So determinant A3 is calculated as 7 multiplied by negative 2 multiplied by 7 minus 8 multiplied by 3 minus negative 1, so it is plus 1, multiplied by 10 multiplied by 7 minus 8 multiplied by 6 plus 0 multiplied by something. So it will be negative 61. Sorry, negative 244. Now we have to calculate the values of x1, x2, and x3. They are calculated as determinant of a1 divided by the main determinant. So it's negative 61 divided by negative 61. So the value is 1. With respect to x2, it's determinant a2, which is negative 183 divided by negative 61. So the value is 3. And finally, with respect to x3, it is the determinant a3, which is negative 244 divided by the main determinant, which is negative 61. So the value is 4. So this is how to find the values of x's, x1, 2, 3 using Cramer's rule. Thank you and see you next week.